Hello everybody, in this video I'm going to code a bouncing circle as fast as I can in pure C. So let's just go right ahead and create a file that is called bouncing_circle.c, and let's include STL2, which is the graphics library that we're going to use, and then let's create a main method that will print out something. Hello circle, just like this. Then let's include standard.io.h to be able to print out what we want to print out. And let's go over to this line right here, to this pane right here, and execute the compilation command for STL projects, which is this one. I just need to change the output file name to bounce and the input file name to bouncing circle, and that should compile. And let's execute bounce and see what happens. Nothing happens except the printout, of course. Then let's initialize the project. Let me just do the following. I'm going to do STL init, and we're going to initialize this with the STL init flag for video, because we're rendering graphics. Then we will create a window, let's go and call it bouncy or bouncing circle, and the width of that window is going to be the position, the X position will be STL window pos center, and the Y position will be centered as well, window pos centered. The width will be width and the height will be height. Let's define those variables up here. Define width is equals to or is 900, and define height is 600. There we go. This creates a window, and this will be an STL window pointer p window that is equal to those. And I forgot the last variable, that is the window flag, which we can use as 0. Then we need to create a renderer. STL create, is there something like create? Let's go. Create window and renderer. No. Let's look that up quickly. STL2 renderer window. Create window and renderer. That's wrong. Create renderer. Create renderer accepts a window and some whatever, I don't know. Let's create that variable. STL renderer is a pointer p renderer, and that will come on. STL create renderer, STL window, we will pass a window p window, index will be 0 and the flags will be 0. Okay, that is our renderer. Now to create a circle, we do the following. We first have to draw something to the window itself. So let's do STL clear renderer, or render clear renderer clear. Where is it? Renderer clear, and then we pass the p renderer. Maybe we should check if that even compiles. Let's introduce a delay of 3 seconds and see if we can start the application. Let me just put everything in one command, bounce, and there we go. This is our window. It's still black because it doesn't contain any graphics. We haven't rendered anything yet. So let's renderer. Is there something like render a pixel? Render draw point sounds reasonable. So let's go to the documentation and look up STL render draw point. And we have we pass the renderer and a point X and Y. Let's see. p renderer, and the x and y are going to be 50 and 50. Let's see if we can set a pixel. Ah, no, and one thing that I forgot is we have to now update the renderer, and then there should be something like update or render copy flush. No, that's all wrong. Come on, I want to do this fast. SDL renderer update. Render present, yes, that's it. Render present, come on. SDL render present p renderer. There we go. And let's draw the pixel. It's black because we haven't set a color on the renderer. So let's make it SDL renderer color. Let's go to the set render draw color and make a red point. Let's go SDL set render draw color. I will copy all of this. Let's go down here and set the renderer draw color here. 0x 0x 00x 000x 000x 00. Let's see if that works. And there's a mistake. 1 2 3 4. We receive an integer. We pass the renderer. I've passed too many variables. Okay, let's go. And there's our red circle almost. Let's go. Ah no, that's fine. No, it's not fine. No, that's not fine. We clear the renderer. Then we draw a background. Let's draw a background. SDL render rectangle maybe? Is there a rectangle? Render fill rect p renderer. I bet the API is going to be something like this, where we pass a rectangle here. So then let's go and define this background rectangle. SDL render SDL rect background rect is an structure. SDL rect. I'm not sure about that. And it's going to be width, no, 00 xy, width and height. And of course use a curly brace, and that is the rectangle, and then we pass the address of that rectangle into this function. There we go. It's still not what I expect. I want to just set a single pixel. Fill the rectangle, background rectangle. We fill the rectangle. Of course we need to update the renderer draw color. Possibly here, let's make it all black. Is that black? That is black, yes. Now I want to draw that single point in a different color. So let's make it red. There it is. This is our single red point. I think we can render a SDL render fill. No, wrong. SDL render fill rect. No, we should draw a point. Now instead of drawing a point, let's draw a circle. Now there is no pre-made circle drawing method, so we have to create one, and that is going to be this one right here, is a void, and we are going to draw circle. We're going to accept as input an SDL renderer pointer, p renderer, and then we're going to accept as input a radius, double radius. And that should be enough, I think. So how do we draw a circle? We have, we also need a center point, of course. So let's define an x or double x, double y, and then the radius. And then for int I equals, for int I equals, and then we start from x minus radius, and then we go up to I smaller than x plus radius, I plus plus, and then we do the same for y. Let's call that, no, let's keep it that I. Then we do y, j equals y minus radius, j smaller than y plus radius, j plus plus. Ah, God. And then we do, where did my keyboard go? And then we do SDL, and we draw basically a single pixel. So let's copy that down here. And we draw that pixel only, we fill it only if it's inside the circle. So if the coordinate, current coordinate is composed of I and j, so if that coordinate, the distance, and we have to use, or we can use, we don't have to use it, but we can use it. If the distance double dists, let's make those integers doubles as well, just to have precise calculations. The distance is the absolute of the, no, the square root of, and then we power j minus, or I minus x, doesn't really matter, to the power of 2 plus power of j minus y to the power of 2, square root of that. Square root is optional actually, but that is the distance. If the distance is smaller than the radius, then we draw the point. Come on. There we go. Let's see. Of course this doesn't work. First of all, I have to draw the point at a specified coordinate, and we have to say the coordinates I and j. And there's still a syntax error. Does it expect braces here? I thought it shouldn't, but apparently it does. Let's see if we... No. Expected comma or semicolon. I forgot a... Let me just enable all those line numbers so I can jump around faster. Let's compile this now. It's not working because the math compilation library math.h is not linked, so let's do lm compile. Where's our circle? It's gone. It's not there. Maybe let's make the circle green here. Make circle red here. Let's make it red. Then we set the renderer draw color. Then we render present whatever we have drawn here. Let's go. And it's black because we're not calling the method. Then let's draw circle. We draw the circle by calling the method draw circle, obviously. How else would you draw a circle? It can only be drawn through the draw circle method, and that is the only means to achieve an end. So 50, 50, 20. Let's draw the circle and see how it looks like. That is the super speed application. There's our circle. Awesome. Now let's close this. Now let's make the circle bounce around. I would first make the circle a bit bigger, much bigger actually. Let's make it 60. This should, yes, it works. Awesome. Now make the circle bounce around. How do we do it? We have to create an event loop, int quit, while the application is not quit. Quit is wrong. While not quit, we do the following. We loop over the events that happen. First we create this while loop. SDL event. Let's do while. Let's poll all events. SDL poll event. Let's check the address, or let's pass the address of event, and if something happens, how do we check if something happens? We have to check if an event occurred, event.type.SDL quit or something like this. I hope this is correct. SDL quit, there is a suggestion for that, so that is a good, no, this is wrong, because we have to check SDL event dot, something must happen here, so we have to check the events that happened. So we have to check SDL event type, there's a type. We have to check SDL type quit. Let's check the quit event, the definition of that. What can we see here? SDL.type.quit or SDL.event.tip, or SDL event.type equals SDL quit. Let's see like this. Maybe this is stupid. Let's delete all of that. I don't think this is very efficient. We have to check if event.type is equal to SDL event. Is it possible? No, SDL quit. Is it possible that I just deleted the code and coded the same thing again? Probably my brain decided that it's still a good choice. And let's do printf quit application, new line, and then let's set quit to true. Let's compile all of that and run it, and if we quit, then it quits. Awesome. Now we can change the coordinate of the circle, or we can draw new circles. Let's draw a new circle in the loop that is the event loop down here. And here we can do the following. Let's indent those lines first. And then let's do the following. Let's define a velocity for the circle. How do we do that? We have to define a structure, struct circle, a circle, and a circle consists of, where did it go? What the hell? We have to define a struct circle. That struct consists of a position, double x, double y, double vx, which is the x velocity, double vy. I think that's it. Then we can draw a circle, and we draw it based on a structure instead of based on the individual coordinates here. Circle, struct circle, p circle. That doesn't work, obviously, because we haven't adapted the code. So let's go back to the radius. We are now here. Let's do circle radius. Circle radius. Circle, and we use the arrow pointer because we're accessing the arrow. I can't speak right now, sorry. Circle radius. I think this should work. Y minus circle radius, y plus circle radius, and then there's a circle radius here. Let's see if that compiles. No, it doesn't compile, obviously. Do I mean circle, struct circle, what? Double y, expected identifier, y. Do I have to do this? What does this error message say? Circle undeclared. Do you mean circle? Of course the circle is not declared because I have to first do the following. Struct circle. Circle is equal to struct circle, and it receives coordinates and radius. And then I pass as input the address to the circle. That doesn't work, of course. Note, expected struct circle, but argument is of type struct circle, struct p circle. What? Of course, I have to make this a pointer. So let's try again. There's a y minus c somewhere. Y minus circle, the radius, circle radius. What's the issue there? Y minus circle radius. Of course, double y is equal to circle y, and also double x is equal to circle x, and that should be it. Of course, it's not it. Circle y, p circle. Oh, yeah, of course. No, damn it. Let's forget about the p circle for speed reasons. I will update all of the structs. Circle has no named radius. It doesn't have a radius. Double radius. Okay. Then the radius, let's say the velocity is 10, 10 radius, and the radius is 60. And there we go. This is a circle that is being rendered based on what is written into the structure. That is awesome. Now, update velocity or update position. We update the position of the circle. We pass the circle as input right here. Let's create a new method. Void update position of the struct circle p circle, and that is a pointer. So double new x is equal to p circle x plus p circle vx. Oh, my brain is shutting down. My brain is shutting down. What the hell? Hey. There we go. There we go. Those are the new x and new y positions. The speeds can, I think, stay the same. I don't know. No, they can't, because we need a velocity. So this is not enough. We need a double ay, and we need an acceleration. I mean, ay, ax, ay. And those are new numbers here. 10, 10, 10, 10, x. The circle is still being rendered. So those are the new positions. What do we do now? We code new velocities. New vx is equal to p circle vx plus p circle vy. No, bullshit. Plus circle ax, of course. And then double, no, we don't even have an ax because we don't have, wait, no, we just need a gravity. Let's call it gravity. We don't need an acceleration in x direction. just like this. And gravity is pointing downwards, so let's make it -10. So Vx plus gravity, and same is Vy is constant, so we don't change it. Then we update the position of the circle and we draw it. Okay, that means we can now on the circle, on P circle, we do x equals new x and y equals new y. And of course also Vx equals new V. No, this must be Vy because only the y speed changes. Vy. Okay, good. Okay, the circle is not moving. Why is it not moving? We are updating its variables in place here. We are generating a circle here. That is wrong. We have to generate it outside of the structure so it can update independently outside of the loop, and there this worked. This is awesome. Of course we have to clear the old circle, and we do that by clearing the screen. Renderer clear, probably. Let's do a renderer clear inside the loop. Here, let's go. This is wrong. Set render draw color. Let's also do that. And this sets a black background. And this was our circle moving down, which is awesome. That was too fast, so let's introduce an SDL delay of, let's say, 50 milliseconds. That looks shit because it's too slow. That looks fine. Then let's do new x, new y, new vy. The speed, does it update? X updates is updated as per the speed. Same for y. Then new vy updates as per the gravity. Circle vy, new vy. Of course that is wrong, because here we have to say this. Let's see how the circle moves, and it moved upwards. Something was wrong, of course, because the gravity must be negative. Let's go. There it moved down. Now, in update position, we also have to check if the circle, if P circle dot x is bigger than or is smaller than 0, or P circle x is bigger than width plus radius. And of course we don't check 0, but 0 plus radius and width minus radius. Then we invert the P circle Vx component is equal to minus P circle, damn it, P circle Vx. So we invert this component, and we do the same thing for y. So basically we can probably just copy this and do a replacement of all occurrences of x, replace all of them with, oh, damn it. No, let's do manually. Let's do it manually. Something doesn't work. V, y, like this. Okay, and then of course we have to adapt the checks here. Y, if y is smaller than radius, and this is bigger than height minus radius, then invert. Let's see if it doesn't compile. Why does it not compile? It must compile. But the radius is wrong. I need to extract it in a variable. Double radius is equal to p circle radius. Okay, let's go. And this looks weird. Then we do... of course we have to invert the speed, but also we have to set it at a position. P circle dot x is equal to 0 if it's the radius case. So let's delete all of that. P circle x 0 if it's the radius case. Let's copy all of that. If it's bigger than the width plus the radius, then we have to set x as width and invert the speed. And let's do something similar down here. We change y and set it to 0. No, we don't set it to 0. What am I even doing? We set it to radius, obviously. And then I am setting x to radius here as well. And this to width minus radius. And then in this case, in case y is bigger than width, height plus, minus radius, then I do is equal to height minus radius. Let's see if it works now. Will it compile? Yeah, it's just getting faster, but that is fine. Or, well, it's not fine, but it's fine. We have to add some variable here. Dampening. And with each bounce, we set int bounced to true. No, that's not good. Dampening. Depending on the dampening, of course, we have to say p circle vx minus equal p circle dampening. Something like this. Same here, just for y, and same thing here, just for y. Okay. I forgot something somewhere. Did I duplicate curly braces somehow? What the hell? How did I accomplish that? Of course it doesn't yet work because I'm not passing in the struct circle creation, where we create this struct a dampening factor, or a dampening, this is not a factor, it's just, wait, let's just try this value. I'm already sweating. Why is it getting faster? Dampening. Let's multiply it with the dampening. I don't get it. I have to state that the dampening is something like this. Bullshit. I was appending the dampening to the color, which is wrong, of course. 0.9 is the dampening factor. Let's execute. And there, that looks okay-ish. That is fine, and I would consider that. Let's do 0.5. Oh, that looks good. Let's do 0.8. Let's do 0.7 and let's see. And there we go. This is our bouncing red circle. I hope you enjoyed this speed coding video, and if you want to see more of that kind of stuff, then please subscribe. For all the projects of this in this video on this channel, oh god, my brain is so mushed right now. All the projects on this channel all the projects that we coded together on this channel are available on GitHub. They are available to Patreons, so you can just sign up to my Patreon and then contact me, reach out, and then I will invite you to the private repository there, which is awesome for learning C and Python and whatever other programming languages we use so far. And you can just execute all of that code yourself locally. All right. Then I hope you enjoyed this video, and see you next time. Bye.